While number one, intelligence can be shaped after birth. The old thinking was that biology is destiny. IQs were thought to be born, not made. Certainly, some kids seem naturally smarter than others, right from the get-go. But we now know that the sum total of a baby's intellectual capacity is not fixed at birth. A child is born with an IQ range that can vary by as much as 20 or 30 points. While genes and physical health set the stage for some of a child's future behavior, we now know that a child's IQ and ability to function well also depends on the environmental experience that she is exposed to on a consistent basis. Think of healthy brain development as a dance between biology, what your child was born with, and early care, what happens after birth. The two are so intertwined, scientists are now examining factors in the environment that can either hinder or facilitate the way that genes operate. We used to think genes functioned in a static way. If you had a gene for something, you showed that trait, like eye color, for example. However, we now know that some genes can be dormant. Whether or not they get turned on depends on experience. This is a dramatic new finding. Your baby's consistent early experiences may actually protect against the turning on of certain genes involved with unwanted traits, such as hyperactivity, compulsivity, and aggressive behavior. An amazing example of the power of life experiences to alter the destiny inscribed by our genes. Inscribed or inscribed? Hold on for a second. Inscribed by our genes can be seen in monkeys. Those born with one particular variation of a gene grow up to be extremely aggressive when they are poorly bonded to their mothers during infancy. Yet other monkeys who also have this gene variant do not become aggressive when they have developed a secure relationship with mom. Despite the monkeys in each situation having the same version of gene, they have different levels of the chemical that is produced by the gene. This indicates that life experiences in the early years can actually change how certain genes function. What's more, because female monkeys go on to mimic the same kind of attachment relationships with their babies that they themselves experienced, it's possible that behavioral tendencies that were long believed to be directly transmitted through one's genes, like aggressiveness, may be transmitted through social learning instead. Dr. Stephen called this the buffering effect of good mothering. Talk about the power of experience. We don't yet know for sure if this type of animal research is directly applicable to human behavior, but such new findings highlight basic neurobiological principles that likely hold true for us too.